This is Group 22. Our work is about long sentence preprocessing in neural machine translation. Our group member includes Yang Weihua and Mo Yilong, and this is Mo Yilong. Please let me introduce our work at first. Our presentation includes four parts: introduction, methods, experiments and results, and finally discussion. Now is the first part, introduction. After reading some related works, we find that there are some challenges for NMT, including out-of-domain, amount of training data, low frequency words, long sentences, word alignment model, and so on. And we focus on long sentences in NMT because in processing long sentences, NMT usually achieve not so satisfying results. And currently, many NMT systems like OpenNMT often remove overly long sentences from the training parallel corpus. So here are some related works that give us some ideas about how to process long sentences in NMT. And we decided that our work is to learn how to learn and replicate the method proposed by Tian and Lin, which includes build a phrase-aligned bilingual corpus via extracting bilingual phrases, and then use the phrase-aligned bilingual corpus to train neural machine translation system. And finally, we compare results with a baseline system. The second part is the methods in our work. The main idea is that instead of removing long sentences, more than 30 words from the training parallel corpus, we break down these sentences into phrases and put them together in the training corpus, and then use the training corpus to train our NMT system. The processing includes three steps. The first step is to extract sentences of more than 30 words from the original sentence-aligned bilingual training corpus and get a new sentence-aligned corpus. And then we select phrase pairs which meet the condition into the phrase-aligned bilingual corpus. The third step is to mix the original sentence-aligned bilingual corpus and the phrase-aligned corpus together and use this corpus to train the NMT system. When generating the phrase table, we also separate it into three steps. The first step is to use GISA++ toolkit to process the bilingual sentence pairs to be a word-aligned file, and then we use MUSIS. An aligned phrase table is generated from the training corpus. All these aligned phrases are dumped into a big file, and then we score the aligned phrases in estimating the phrase translation probability PVE and its inverted probability PVE. After getting this phrase table, we come to the bilingual phrase extraction part, and it's our algorithm about how to extract phrases from original corpus. We input sentence-aligned bilingual corpus, and the output is phrase-aligned bilingual corpus. So we firstly begin with the phrase table generated by MUSIS, and we process the phrase table by using SALM tool to remove redundant phrase pairs, and then we find the source sentence and source phrase and target phrase which meet the condition that PVE plus equals to PEV equals to 1. And that is the third part.
Now this is Yang Weihua. I will introduce the experiments, results, and discussion of our group work. In the experiments, we're using two type models of OpenNMT to train a neural machine translation model. The baseline model is an LSTM encoder-decoder model with 6 layers and SGD optimizer. Beside the tuning steps, 100,000 and validation steps, 5,000. And another model is transformer model with 50,000 pairs phrases extracted from the training site. Because of the poor performance of LSTM model, we changed the model type and used the transformer model. This model has the same layers and the training steps and the validation steps as the baseline model. And the differences are the optimizer and the learning rate. We use the ADM optimizer and set the learning rate is 2. The baseline model took 10 hours and the transformer model training process took 22 hours. Next, in the experiment and the training process, we used the common corpus of WMT 20. The training set with 300,000 number of sentence pair. And in the validation side, we used the 5,000 number of sentence pairs. And in the testing side, we used only long sentences of 1,970 sentence pairs. For the results, we used the statistical machine translation model as a comparison. In the statistical machine translation model, this model achieves 9.63 BLEU scores, while for the OpenNMT, the 2 types of OpenNMT models, the performance are poor. With the baseline LSTM model, which without phrases extracted from long sentence, achieves 1.1 BLEU scores, and the other model of transformer with phrases extracted from the long sentence achieves 4.3 scores. So, why our NMT models is not satisfying? We think there are 4 reasons. And the first one is we don't have enough size of corpus. So the training set didn't provide the rich features. The second one is lack of data normalization. So if you use the data normalization, the performance will be improved. The third one, without fine-tuning, using pre-trained model. Using pre-trained model will speed up training process and will achieve good quality. And the first one, we didn't set proper hyperparameters. In the future work, we will fix the problems and improve the model quality. Thanks for watching.